Hi guys, we're on 114 still. We're going to work a couple more word problems. We'll do both of these examples on this page, give you a little bit more practice with setting up these rectangle problems. So example number 2 is similar to example number 1, but of course it's different. So it gives us some information. You should always be drawing a picture on these. Never, never, never try to do this without a picture. A picture makes it make a whole lot more sense. So it gives you something about the rectangle to begin with. It says it's twice as long as it is wide. So if I let the width, this is the original larger red rectangle, be x, then his length would be 2 times as big, which is 2x. So that's where we're going to start. That takes care of that information. Then it's telling us that the length is getting smaller. So this is my interior rectangle. It says this rectangle, this 2x, is getting smaller by 4 centimeters. So his dimension is now 2x minus 4. And it also tells us that the width is decreasing as well by 2. So x minus 2 is the width after you decrease it. So it's really important that you understand this particular concept to be able to go forward with many of these problems. So that takes care of that second sentence. And now they're asking us to find the original dimension. So that's the red rectangle. What is the length and what is the width? Well, we've got to come up with an equation here. We have to have some way to solve an equation. And it does tell us how much the area is decreased by when we make these cuts, when we make these lengths and widths smaller. So this is helpful to us because if in looking at this now, we know that the area of the big rectangle minus 24 square centimeters is actually going to give us the area of the smaller, the reduced rectangle. So this is going to be our equation. This is our verbal model. This is what we're trying to set up. So we can calculate the area of the big triangle, length times width. So it's 2x times x minus 24. And the area of the smaller rectangle, we're going to need grouping symbols. We're going to need parentheses around these because there's more than one term. So again, it's length times width, which is 2x minus 4 times x minus 2. And now we need to just clean this up and solve for x. So I'm going to kind of just run through this. I'm not going to talk through every single step. You can follow with me, and when I get to something important, I'll mention it. This is double distribution over here, so we're going to take the 2x and multiply it times x minus 2, and we're going to take the minus 4, do not forget the sign, and multiply it times x minus 2. We've got a bunch of stuff to clean up on the right, so we'll leave the left, this guy alone for a few minutes. Wish I had more room, but I don't. So I'm going to subtract 8 from both sides. So x is equal to 4. Now, if you come up with x as a negative number, and you know you've done something wrong. You cannot have a negative width. So that's a good check here. So x is equal to 4. And then double x is 8. So the dimensions are 4 centimeters by 8 centimeters. Do not forget your units. Let's look quickly at example number 3. This oil painting is the subject of our attention. The oil painting is 10 inches longer than it is wide. So the painting's in the middle. He's got a frame going around him. But the painting on the inside is setting up like this. He's 10 inches longer than he is wide. It tells us that this frame is 3 inches all the way around. So it's 3 inches here, 3 inches here, 3 inches here, and 3 inches here. So we need to get the dimensions of the larger rectangle as well. So it is going, the length is going to be the original x plus 10 plus the 3 on this end plus the 3 on this end for the frame. Do you see that? 3, x plus 10, 3. And so, of course, that's going to be the same down here, which is x plus 16. And when we're looking at the width, you've got your original x right here, the 3 that you're adding on here, and the 3 that you're adding on for this side, which gives us a width of x plus 6. So now what are they asking us to do? They're telling us the area of the frame itself. Take out the painting. The area of the frame itself is 402. What are the dimensions of the painting? So I'm going to set up a verbal model here. Basically what we're doing is we're adding the inside, area of the inside, plus the frame area, and that is going to equal the area of the large rectangle. So if you add the little bitty painting area and you add the area of the frame, it stands to reason that that gives you the total area of both of them added together. So this is going to set up a pretty long equation. I'm going to go ahead and write it. The area of the inside is x times x plus 10. The area of the frame is 402. They tell us that. The area of the larger triangle is x plus 16 length times width, x plus 6. So we're going to go clean all this up and solve for x. X squared plus 10x plus 402. Double distribution, x times x plus 6 plus 16 times x plus 6. So over here we can't do much yet with this side until we clean up the right-hand side. X squared plus 6x plus 16x plus 96. Okay, let's combine those terms on the right-hand side. X squared plus 10x plus 402 equaling x squared plus, what is that, 22? 22x plus 96. Now I can start getting this stuff cleared out. Subtract x squared from both sides, and I've got 10x plus 402 equaling 22x plus 96. So maybe I'll get the x's together. Okay, don't be afraid of weird numbers. You can have an inch within, doesn't have to be a whole inch measurement. So just make sure you've done your work correctly, and I have, I think. So my x is equal to 25.5. My x, remember, is the little guy on the inside. So let's go back up and see. I've been working so long I don't even remember what they asked me for. What are the dimensions of the painting? So I go back to the inner painting. I found the width, and the length is just that plus 10. So 25.5, and this is inches, by 35.5 inches, because we add 10 to get the length. So these are long problems. They're not particularly difficult, but as you can see, there's lots of places to make mistakes. So what we'll do is we will do example 4 and 5 in class, and I think what we're doing is putting example 6 on the video check. So just make sure you understand these, and we'll come to class and do the rest of them. Thanks for watching.